Hi ladies, today we'll be working on converting problems. So if you are ever in trouble, think of money. That's the best way that I can think of conversion factors. So anytime you have a dollar, you have something that is equal to 4/4, or it's equal to 10 dimes, or 20 nickels, or if you're really adventurous, 100 pennies. So the same thing is true for scientific qualities or quantities, but they're a little bit different since we don't use them every day. But the nice thing is they're always based on units of 10. So, for example, 1 meter is equal to 10 decimeters, which is equal to 100 centimeters, which is equal to 1,000 millimeters. So the nice thing is I'm going to give you all of the conversion factors you're ever going to need on the test. Okay, so you don't have to worry about memorizing all of those different things. However, you have to know how to use them. So whenever you're making two measurements that are equivalent, a ratio of two measurements is always equal to 1. So for example, if you want to think back to our money problem, if you had $1, that is equal to 4/4. So the equality for that example would be $1 over 4/4, or 4/4 over $1. Now, if you were to figure out how much 4/4 equals, that's also known as $1. If you were to divide these two, that's going to give you a quantity of 1. So the reason that we do this is because we want to make sure that we aren't changing the original number that we are trying to convert. So when you apply this to different things in your scientific measurements, you'll see something like as follows. You would have 1 meter is equal to 100 centimeters over 1 meter. And this is exactly like the example of 4/4 over $1. So the meter is the larger unit, just like how the dollar was the larger unit in our money example, and the smaller unit has this bigger number with it. And you can use the same idea in reverse, where you put the larger number on top and the bigger number on the bottom, as long as you keep the larger unit with the 1 and the smaller unit with the larger number. So the ratios that we just went over are called conversion factors. And they are simply the equivalent measurements of different units. And the conversion units are these two right here that we spoke of in the last one. And you can read these as 100 centimeters per, that's just another way of saying divided by, 1 meter, and 1 meter per 100 centimeters. Both of those are the way that you would write and read those conversion factors. So whenever you are writing these conversion factors, they're going to help you solve problems in which the number that you're given needs to be expressed in a different unit. And they have unlimited significant figures. So that means it is an exact measurement. So it does not change the number of significant figures that you start with. That's important to remember. Write it down. You can do this with any of the metric system units that I will be giving you for the test. So the relationship between grams and kilograms is a little different. Even though grams is our base, kilograms is our bigger unit. So remember, the bigger unit gets the number 1. And the smaller unit tells how many of those smaller units make up one of those bigger units. So they get a big number. So for example, here we have kilograms, which is our bigger unit, grams, which is our smaller unit. So kilograms has 1 and grams has 1,000. And the sheet that I will give you will tell you that kilo means 1,000, so that means that there must be 1,000 grams to make up one of those kilograms. The conversion factor could also be written as the reverse, in which it is 1 kilogram per 1,000 grams. Here is another example with a very, very small unit. So meter is your base unit, and it is the big number. So it gives the number 1, and then your smaller unit tells how many of those smaller units are required to make up that one large unit. Therefore, it will be 10 to the 9th. Again, all of these quantities will be given to you. Many of these problems that you are going to see in chemistry are going to utilize this type of conversion factor and dimensional analysis. Dimensional analysis is a way to solve problems using the units to figure out not only the answer, but also the units of the measurement. So let's take a look at the sample problem. So here in our sample problem, it's asking you how many seconds. So seconds is our unknown. Are in a workday that lasts exactly 8 hours. So you know that you have 8 hours. Okay, so we know the following conversion factors. 1 hour has 60 minutes within it. And if you need this, I would be happy to provide it on a test. 1 minute is made up of 60 seconds. So we are going to use dimensional analysis to figure out how many seconds are in 8 hours. So you start with writing what you know, and you draw a line and over 1. This doesn't change the quantity, because anything divided by 1 is still the same number. However, it makes it easiest for when we go to multiply everything. So this is required on a test. You multiply by, and then you draw a line. Now to cancel out hours, if you had something on the top of a fraction, to get rid of it, you would put the same thing on the bottom of the fraction. So you'd put hours on bottom. We have one conversion factor that will allow us to figure out how many minutes are in this 8-hour workday. So we're going to use the first conversion factor, and that has 1 hour, and on top we would put minutes, because that's the only thing we know for our conversion. But we still are not to seconds, because we can cancel out hours because it's on the top as well as the bottom. We need to now cancel out minutes. So we draw another multiplication sign, draw a line, put minutes on the bottom because that's what we need to cancel. And we're going to use the conversion factor that we are given with minutes that'll get us to seconds. So that would be the second one. So we would put our seconds on top. So there's 1 minute, according to this equality, is equal to 60 seconds. Now we cancel out the things that match from the top and the bottom, and we are left with seconds, exactly where we want to be to find out the answer to this problem. So if you were to multiply straight across, you would get 28,800, and our units would be the units we are left with, seconds. So our answer would be 28,800 seconds. We've canceled out everything we've needed to, and our number is much larger than what we started with, which is expected. All of this is also in your notes or in your PowerPoint if you need to have an explanation in writing as well as verbally. So you are more than welcome to try that as well. You can also apply this same dimensional analysis to things that are not specifically units. So, for example, the directions for an experiment ask that each student to measure 1.84 grams of copper wire, and we only have a spool with a mass of 50.0 grams. So we have to figure out how many students can do the experiment before all the copper wire runs out. So the first thing I like to do is write our conversion factor or our equalities. So for this experiment, you would have 1 student per 1.84 grams of copper. Then we would write our known and our unknown. So we know that we have 50.0 grams of copper, but we don't know how many students we can help. Then we want to write our plan. So you want to start with the information that you were given, so the amount of copper, and we want to get to the number of students. Okay, well, we have an equality just for that. Now we can do our conversion. So we start with our 50.0 grams of copper over 1 multiplied by, now to cancel this out, we must put it on the bottom. And according to our conversion factor, we have students on top. So 1 student equals 1.84 grams of copper. Since the grams of copper is on top as well as on the bottom, they cancel out and we're left with students. And that's exactly what we need to know. So we would multiply straight across and divide by the quantities on the bottom, and we would get 27.17 students, or let's just round that to 27 since you can't have 1/10 of a student. So overall, our number would be 27 students. This is also drawn out in your PowerPoint if you would like to go through this again. You are more than welcome to. And we will talk about conversions even more in our podcast for tomorrow. See you then.